So thank you for joining the 5th webinar in the OASIS USV for the Global Ocean Observing System community of practice. And the purpose of this webinar is to generate a community around the emerging network of uncrewed surface vehicles as part of the emerging GOOS network. And so welcome to returning and new participants. And if you're interested in getting involved in OASIS and this emerging network, please visit our website, which is on the screen there. There's an online registration form, or you can directly reach out to Meghan, myself, Sebastian Swart, or Sarah Nicholson if you're interested in participating or presenting at any of these webinars. So today we're going to hear about what's happening in Australia and the Pacific. And because we are an emerging network, we welcome expertise in analysing data from other networks. And so similar sort of data strategies and network strategies can help improve the planning of this emerging network. And so the format of the webinar today is we'll hear from each speaker for a 7-minute lightning talk, and then we'll have brief questions after each speaker, and then at the end we'll have a panel discussion where the audience and participants can ask questions to the speakers. So Colette Kerry, Dr. Colette Kerry with the University of New South Wales is up first. Colette, are you able to share your screen, please?
Okay, can you see my slide?
Yes.
Yep, okay. So yeah, while I don't work directly with uncrewed surface vehicles, we've done some work on observation impact from other platforms in the East Australian Current. So I'm going to talk about that today. My research focus is variational data assimilation and specifically observation impact, so understanding how different types of observations and observing different locations might impact our model state estimates and forecasts. So over the last few years, I've been focused on developing a high-resolution forecast system for southeastern Australia. And today I'm going to focus on this regional configuration of the East Australian Current. So there's a little animation here. Basically, the East Australian Current dominates the circulation along southeastern Australia. It typically flows as a coherent jet sort of to the north of our domain before separating from the coast and generating an energetic eddy field in the Tasman Sea. The period that I'm going to talk about today is a 2-year period, which was quite heavily instrumented because we had the sort of beginning of the integrated marine observing system in Australia. So these little dots that are flashing up are the observations that we have over the 2-year period. So we had a deep water mooring array here off of Brisbane, various Argo floats in the magenta. So I'll play that again. We had some CTD observations from ships of opportunity, various coastal moorings, surface currents from a high-frequency mooring array, a high-frequency radar array, some gliders, and then I also assimilate surface observations from satellites. So like I mentioned, we're going to focus on this sort of 2-year period, which was a decade ago now, but it's interesting because we had this sort of wealth of observations. And I'll try to focus mostly on surface observations, but also show what the value that we found in the subsurface observations. So we nest in a global model. Our regional model has a 2.5 to 6 kilometre resolution, and with a higher resolution over the continental shelf and slope to better resolve that bathymetry, which is important for how the East Australian Current interacts with the coast. Okay, so to begin with, we generated sort of a long-term free running model, and we showed that it accurately represents the mean and variability of the circulation. Of specific interest in the EAC is the sort of percentage occurrence of separation at various latitudes. So our model does well compared to satellite data in representing that, and also the depth structure of the current. Okay, but then obviously if we want to make predictions, we need to use data assimilation to regularly correct the sort of timing and location of the mesoscale eddies. So in our case, we do that every 5 days. So we run a 5-day forecast. We then assimilate data, and then using a 1-day overlap, we then run the next 5-day forecast and so on. So the data assimilation method that we use is 4-dimensional variational data assimilation, which uses the linearized model equations to minimize the difference between the model and observations. So essentially, we're using subsequent iterations of the tangent linear and adjoint models of the ocean model to compute increments in the model initial conditions, boundary conditions, and forcing, such that when we run a new solution of the nonlinear model, it better represents the observations. So this is sort of represented by these schematics here, where we come up with an analysis, which is a complete solution of the nonlinear model equations, but better represents the observations. And then that's used for improved initial conditions for the subsequent forecast and so on. So our 2-year reanalysis, basically this slide just shows that our reanalysis, which is shown by the magenta, has considerably reduced errors than the free running model, which is in the blue. So for sea surface height, errors of about 5 to 6 centimeters. This is sea surface temperature. And then the error reduction in the subsurface is shown here in potential density as measured by Argo floats, which are assimilated, and then also as measured by some independent observations. So showing that even outside of sort of where we're observing, we're getting error reduction across the model domain throughout the subsurface. Okay, so what we're interested in today is observation impact. And with 40var, we can actually directly quantify how individual observations contribute to changes in our circulation estimates. To do this, we need to come up with a circulation metric that's a scalar quantity that's a function of our model variables. So we looked at 5 different metrics, a longshore volume transport through 4 different sections as we move from sort of a mostly coherent jet off of Brisbane down into the eddy field, and then also spatially average eddy kinetic energy. So we're able to then look at each 5-day period and look at the difference between our forecast and our analysis, which is shown here as the increment. And then we can quantify how each individual observation platform contributes to that increment. So how that transport was changed in our model state estimate and how each individual observation platform contributed. So this plot's somewhat messy and not very informative, but basically it shows you that the observation impacts are flow dependent, also dependent on which observations are available in each 5-day window. But we can do some interesting things with this. So in this slide, we're looking at our 4 different transport metrics. So we're looking at transport through Brisbane, where the jet is most coherent, and then moving along the coast into the eddy-dominated region. And then in each latitude bin, we're taking the observations that were available in each latitude bin and plotting how those observations impacted transport through the various sections. So the top plots show the summed impact, so the total impact of observations in each latitude bin, and then this plot shows the number of observations. And then down the bottom, we've got impact per observation. So what's interesting here is that observations in this higher variability sort of eddy-dominated region had a greater impact on transport per observation than the observations upstream. So basically, this shows the value of really the value of observing so high variability regions. which was somewhat counterintuitive for the East Australian current, because we thought, well, it might be more important to observe the coherent jet, and then that will tell us what's happening downstream. But in fact, we found that it was particularly important to observe the eddy field. So subsurface, which we're not so interested in here, but we also found that the impact per observation was greater in the sort of upper 400 meters, where we're constraining the depth of the thermocline and the mixed layer. And then basically this table just pulls out the main observation platforms and then looks at the mean percentage observation impact over the 2 years. So the mooring array off of Brisbane was particularly impactful and had impacts all the way downstream, so sort of like even up to 1,000 kilometres downstream. The gliders, which measured temperature and salinity in the eddy field, averaged over the 2 years, were nothing special, but if we looked at the sort of 3-month period that they sampled the eddy field, they were particularly impactful, with impacts of up to 30% on all of the different metrics. And the HF radar, which measured surface currents off Coffs Harbour inshore, the EAC, had a significantly high impact relative to the number of observations, and this was related to basically getting the cyclonic vorticity inshore of the EAC right. So this plot's just an example where we've got a cyclonic eddy inshore of the EAC in the observations, wasn't present in the forecast, and then in the analysis we're bringing in that cyclonic eddy, which is then seen in the sea surface height field. So on average over the 2 years, this plot here basically shows that we've got increase of negative or cyclonic vorticity inshore of the East Australian current when we assimilate the radial data. And that is not only seen at the location of the observations, but also up and downstream. Okay, how am I going for time? A couple more minutes?
We're over 7 minutes, but I think
okay,
if you can wrap it up, that'd be great.
All right, I'll wrap
you.
it up really quickly. So just another quick study that we did to sort of emphasize the importance of observing the sort of high variability region where compared to the coherent region. And we did some observing system simulation experiments where we had surface observations plus observations either through the upstream coherent region or the eddy dominated region. And we found that observing through the eddy dominated region actually gave considerably greater error reduction in temperature throughout the water column compared to simply observing upstream in the coherent region. So yeah, reinforcing some of what we'd found in the past. So just a quick summary slide. Basically, we found that it was really important to observe the eddy-rich region. The downstream could control the upstream estimates rather than the other way around. Observation impact was far-reaching up and downstream and forward and backwards in time due to the nature of the DA system that we use. And then subsurface observations were particularly important in getting the subsurface right. And our future work now is focused on sort of improving the depth structure basically throughout the model state estimates. And yeah, that's it.
Thank you so much, Colette. Are there any questions from the audience? Nothing on the chat. And we can come back to some of those metrics for how useful, I guess, each different observing platform was. Look really neat and quite exciting, I think, when we're starting to consider how USVs might be valued within some of these types of analysis. Colette, have you thought at all about how USVs, or have you had any experience with or thoughts about how USVs might be able to complement some of the work that you're doing in the EAC?
Not really. We don't have any experience with them as yet, but I think there's definitely potential, particularly in terms of potentially sort of like adaptive sampling of specific eddy events that we have trouble predicting. Yeah.
Awesome. That's really good. All right. thank you. And we'll move on to the next speaker, Meghan Cronin.
Okay,
Meghan, would you like to share your screen?
sure. Okay, can you see my screen? I'm gonna now start this. Can you see it?
Yeah.
Yes, okay. Okay, so I'll be talking about a mission that's underway right now, near real-time observations from the developing El Nino. So I have 3 sail drones down on the equator right now. And this is funded through by NOAA, OMAO, Uncrewed Systems, Operations Center, and the Research Transition Office. Okay, so I'll start with the motivations. This is it's actually what we're funded as is looking at the uncrewed surface vehicles integrated within the Tropical Pacific Observing System. And so the Tropical Pacific Observing System, TPOS, was originally designed to monitor key elements of El Nino Southern Oscillation, the ocean heat content, sea surface temperature, and the surface meteorology. But in the past, well, now it's getting on towards 8 years or so, 9 years, there's been a big international effort, TPOS 2020, to redesign it to make it more robust and more capable. And so now there's pilot studies and process studies and enhancement of the sustained observation. And there's this idea that to better predict the El Nino, we need to have a better understanding of the physics governing the eastern edge of the warm pool, shown here by the 28.5 degree isotherm, and that limits the rainfall, location of the rainfall. And also we need to have a better understanding of the upwelling physics that happens in the Eastern Pacific. But also we need to make the TPOS more capable. We want it to be able to observe the air-sea fluxes, CO2 fluxes, because the Eastern Pacific is the largest source of natural variability in the annual global ocean uptake of CO2. And then there's other applications too that weren't really discussed or within the TPOS 2020, but that are now being discussed of how can we like bring in fisheries applications into the TPOS. And so the uncrewed surface vehicle, because it has so many different sensor systems on it, we can look at all these different applications and make measurements for understanding the air-sea exchanges of heat and moisture and momentum fluxes. We can look at carbon and also fisheries. Here's a picture of Reka Domokos, who is a PI, co-PI on this mission, and standing with Valerie Alain from the South Pacific community. Reka says the addition of acoustic echo sounders will allow us to explore the value and feasibility of using long-range uncrewed surface vehicles to assess the effects of physical environment on the biomass and distribution of organisms within the remote Pacific Island regions as a collaborative effort. So this is an EK80 that can be placed on the drones. So we have, as part of this mission, 3 drones, or we did have 3 drones. Now we just have 2. And one of them has an EK80. The other 2, now just one, has an ADCP on it. But all 3 of them measure full meteorology, winds, air temperature, humidity, barometric pressure, but also solar and long wave radiation to measure the air-sea heat fluxes. And it has an ASV CO2 system for measuring the air-sea carbon fluxes and biogeochemistry, ocean acidification. And so we can look at all of these variables in frontal patterns, convective activity, upwelling maybe, and use these data, place these data onto the GTS for ingesting into operational weather and climate forecasting, and also provide these carbon data for global stock takes and annual mean assessments, and then also for these sustainable management of fisheries. So this is the team. This is my group, is the Ocean Climate Station group. We have actually a postdoc position available, so talk to me if you're interested or know somebody who would like to do a postdoc in Seattle in my group. And we have co-PIs who are, these are all co-PIs, co-PIs in carbon within research, in fisheries, in weather, operational weather, line offices, and so crossing all parts of NOAA. We also have collaborators and partners and colleagues in other parts of NOAA, including, this program manager, Ginny Seltz, and a team of PIs that are looking at these, a future process study that they hope to, they're planning on having for upwelling, looking at the upwelling in the Eastern Pacific and the eastern edge of the warm pool variability. And then also we are reaching out and talking with collaborators and colleagues in the South Pacific community and IRD. So here it is. This is our mission. We started in Hawaii. We went up and did an intercomparison against the Woods Hole mooring. Then we went down to the equator outside of the Kiribati EEZ here. And we did an upwelling experiment here with the 2 ADCP moorings going in squares to try to look at convergences and divergences of flow. And we had the EK80 drone in the middle to see the fisheries interaction with this kind of flow. And then we went northward, crossed this front, and then we got clearance to get into EEZ in Kiribati, and we came down to the equator, swung by the mooring right here, did some intercomparisons, and then headed out to do a zonal section to cross this eastern edge of the warm pool. And now we're coming back. Meanwhile, one of our drones started failing, and it's now heading back to Hawaii. I guess this mission has all these different goals, and we are, the interoperability part is really important to us, and that's why we do intercomparisons with all of the other platforms that are available. If there was a research vessel that could be measuring similar measurements that we're measuring, that would be fantastic, particularly if it was that EK80, having ground truthing of that EK80 measurement. I'll stop there. If anyone has any questions, I'd love to hear.
Thanks, Meghan. Oh yes, please, Christoph,
Yes.
please.
Yeah, thanks for the talk. So I was wondering, coming back, yeah, we could have we're a cruise that we're starting today actually, and we could have actually measured the PCO2. It just we're not aware. There was this interest, and it was not the direct focus of our cruises. But yeah, anyway, for coming back to the sail drones and the EK80, I was wondering, since ADCPs also work on the backscatter, acoustic backscatter, and I guess the TPOS ones are at 75 kilohertz or something like that. I don't remember the frequency of the ADCPs, but there may be different, but I guess 75 is one of the ADCP frequency of TPOS. Maybe it's useful to do a comparison between the ship EK80, the sail drone EK80, and the 75 kilohertz ADCP. Because although the sail drones will not have these frequencies exactly, it would be very useful to be able to calibrate offline afterwards the ADCP signals, because then you would have another way to measure the micronecton on a continuous basis from the ADCPs of TPOS. That has been done in one paper. Yeah, by McFadden was in it, and I think it would be really useful to be able to do that. So retrieve the micronecton using the sail drone as validation and
yeah, well, that's really interesting. I haven't heard of the use of an ADCP to measure the biomass, but we did have, you know, we did do these sail drone intercomparisons and had them, you know, sail side by side. And so, in fact, we can look at the ADCP signal versus the EK80 signal. So that's a great idea.
Yeah, there are a number of papers on that, trying to get from the ADCP the micronecton biomass. There are biases like in every method, but I think it would be, I would be very keen on pursuing this, especially with the ADCP's time series from TPOS. And I think it's pretty, yeah, it's, yeah.
Interesting, very interesting. Okay, and
Christoph, sorry, if you'd like to post any of the papers you're referring to in the chat, please do, if there are any on hand. Sorry, Meghan, what were you going to say?
Yeah, sure.
Yeah, the Dong Xiao wrote in the chat, Dong Xiao is a co-PI on this project too, pointing out that the ADCP that we have is a 300 kilohertz, so it only measures to 80 meters, not to 1,000 meters like the EK80.
But the ones from the moorings, the TPOS moorings, if the sail drone can go by and stay some time around the moorings, then it would be calibration of the mooring ADCPs, which I guess, see much deeper. Yeah,
we did several days at the 155 for one of the moorings, the one that is heading back right now. But also we did it against the Woods Hole mooring up at Hawaii.
Thanks, Meghan. We'll cut this conversation off here, but we can revisit if there's time after the last speaker. So Jérôme, if you're, there you are. Would you be able to please share your screen?
Will do.
Thank you. And Jérôme is, there you go. You can introduce yourself, please.
Can you see the proper version, or do you see the one with the notes?
We can see the one with the notes.
What about that? Still?
Yeah, still with the notes.
Let me try that.
Jérôme, would you like me to present?
Let me see. Let me try. I
Okay.
haven't given up yet.
Okay.
While Jérôme is sorting that out, I can introduce him. Jérôme is the head of the Pacific Community Center for Ocean Sciences. And he's presenting on the rejuvenation of the Global Ocean Observing System Regional Alliance for the Pacific Islands, which is PI GOOS. Okay, take it away.
Thank you, Masha. And it's very good to see some old faces in the participants. Because just as a quick introduction, I was lucky to start my career in Hawaii for 10 years, and that was over 20 years ago. And continuing on to Bermuda, where I was in charge of the BATS, the Bermuda Atlantic Time Series, for the physical oceanography part. And then I joined SPC with colleagues like Christophe in New Caledonia. And since 2 years, I have the opportunity to lead the Pacific Community Center for Ocean Science at the Pacific Community. And that is a new science that was started about 3-4 years ago. So my presentation, since it's the first time I actually participating in those webinars, I wasn't used to the format. So there's going to be much less science than in the previous 2 presentations, but more an introduction of who we are and what we do, and how can we engage in more collaboration. So first thing, SPC, there used to be a South in the name somewhere, but it no longer is. SPC stands for the Pacific Community. It's an international regional organization. We have 27 members, 22 Pacific Island countries and territories, including the Pacific Islands in the North Pacific. That's why we dropped the S. And 5 what we call metropolitan countries, the US, Australia, New Zealand, France, and now the UK since Brexit. So we are a scientific and technical organization, and in many ways, you can view us as an extension of technical services for our member countries. For example, take Cook Island or Palau, they don't have a NOAA, they don't have a weather service or at the level that would be required, and SPC is providing that technical help in those countries, including for fisheries as well. So we're providing support to our member countries, and we also have we're a complete organization of over 800 staff with administrative support. We're organized in divisions that I'll go over, and we have all the admin support that's required for an organization that size. And I'll note also we're a bilingual organization, French and English, so we have all our documents translated and our meetings interpreted. So 2 of the major divisions that make up SPC are one that you might be familiar with is the Fisheries Division, or FAME, for Fisheries, Aquaculture, and Marine Ecosystems. That's the division where Valerie is working in. And there's another division, that one based mostly out of Fiji, and that's the integration from a previous regional organization into SPC. That organization was called SOPAC before, until it was absorbed into SPC in 2011. And that's the Geoscience Division that's working more on coastal oceanography and physical oceanography. So those 2 divisions were working side by side until in 2017, our governing body of SPC decided to establish PICOS to really federate science, ocean science within SPC and in the region. So we got funding from MFAT, that's the New Zealand Foreign Affairs Services, to lay the foundation of this center. And we really started in early 2021 with the hiring of full-time staff. So we're currently 3 full-time staff in PICOS. So over the last 2 years, we're fully operational. We added several projects with the funding that comes with it on ocean acidification, on integrated ocean management, and on marine spatial planning. And last week, we were designated by UNESCO to become the Decade Collaborative Center for the Pacific Island. So the Decade is the UN Decade for Ocean Science for Sustainable Development. And as of yesterday, we were granted by IOC, UNESCO, and GOOS to be the coordinator for the rejuvenation of PI-GOOS, which stands for the Pacific Island Regional Alliance for GOOS, who you might all be familiar with. And our funding is ending at the end of the year, and we are actively seeking a new phase of funding with New Zealand for another 4 years, starting next year. So quickly, the 3 broad goals of PICOS. The first one was, given the size of our divisions at SPC that worked on ocean science, one of our first goals was to better integrate the work across those divisions. You're probably familiar with large organizations. Sometimes work is done in silo and there's not enough collaboration between services, even within a same organization. So that was our goal, to get fisheries and geoscience to work better together. Second goal is to contribute to strategic partnerships in ocean science. That is getting SPC involved with NOAA, with IRD, with CSIRO in Australia, to actively collaborate on regional scientific projects focused on the ocean. And last but not least, this is SPC's mandate is really to help countries work with that, access that science and integrate scientific findings in their ocean policies. So as I said, we only have 3 staff in PICOS, but because we're working across divisions at SPC, is on the left, you can see the team that organized the ocean conference that we held last week in Fiji. So on the right is the official group photo of the entire conference, where you'll see Pacific Island delegates, scientists from Australia, New Zealand, the US. And to the left is the actual team that the internal team from SPC that we managed to put together to throw that meeting. So we're only 3 people, but we can access resources from a lot more within our division. Why is that thing not working? So to get into the subject of the webinar, so these are some of the concrete examples of what we are doing. We have established a new website that brings in all the different projects, and TPOS will appear in it soon, and a catalog of of ocean models for the region that is either created by SPC or that has been created by partners. And I know there's a lot of portals around, but this was really not just a portal, but more a reference site where people can access model data to either work with or to use directly. So we're using also that to publish the model data that is used in some of our publications. For example, we're working on inundation risk in Tuvalu. So there's several papers published, and we can redistribute the raw data or the raw model information on that site. So while the PICOS catalog is new, the Pacific Ocean Portal has been around for quite a while. It's part of a larger program led by Australia and SPC to provide information to our member countries on different ocean observation and ocean products. So that includes tides, that includes ocean projections, and that is currently undergoing a complete rebuild to be compatible and interoperable with other products. And I can touch a few words on that later. And I see that Jim Potemra is in the audience on the collaborations with PACAUS. And as I mentioned, starting this year, SPC will start the coordination of the rejuvenation of PI-GOOS. So PI-GOOS has actually been established in 1998, but it's been very, very dormant since then. And it's really time for rejuvenation of that system, because it's an alliance that aims at really coordinating and making available all the data that is collected in the region for the benefit of our member countries. So if you look on the map, you see the area that PA GOOS covers. It actually even extends further north into the Pacific, noting that some of our member countries, for example, Marshall Islands, have some of a dual membership with PAC-IUS, which is the Pacific Island branch of the US IUS, and PA GOOS, the International Alliance. So in the coming months, some of you might be called upon participating in our first steering committee, and we'll start looking at how we can federate the different observing systems in the region, TPOS being one of them, but also all the different initiatives, ocean observation initiatives in the region that would benefit from improved coordination and centralized data distribution. And I'll leave it at that for now. Thank you. And I might have said within the 7 minutes.
Well, good. Thank you, Jérôme, very much. That was super interesting, knowing more about the history of the Pacific Island goose and how you're rejuvenating that very recently. So thank you for that. Are there any questions from the audience? I have one. Jérôme, how would you see the role of USVs in PI GOOS? Is this something you've thought about at all, or is something that you can see could be useful for any reason?
Well, there's several levels, several answers to that question. So USVs as part of as TPOS, yes, definitely a role in that. For example, our member countries see those data collection systems that goes for the TPOS moorings, but also the Argo floats and now the USVs. So there's a work to do. There's two parts of the work I think we need to do. Is one, to make sure they're aware of that and that they can use the data, or at least we can have the data available to them. Even if it really is, it usually is on individual websites. What we'd like to do is to put everything in one place so that each of our country can access, or this is the data collected in your EZ or in the region around you. And the second is a bit of outreach, and it's been going on for years for the Argo floats, explaining to the country that one single Argo float is not going to revolutionize the science in their EZ, but the network on its own is improving models, forecast models, projection models, global understanding of the state of the ocean, and so on. So we also see a role in outreach in that with PI GOOS. We will not, well, at least not at first, be a funding mechanism, but we're more a coordination mechanism. And so that was for the USV within TPOS and the broader issue of TPOS. We'll also try to encourage, and that's not just PI GOOS, but also PICOS, and some of the discussions we're having with an Australian manufacturer of USVs is SPC is interested, together with IRD as well, on those questions of micronecton and how to increase the coverage in the Pacific for example, with USVs with an EK80 mounted on the hull, or as Christophe mentioned, opportunistic use of ADCP data. So yes, there's definitely some applications of USVs, either by interacting with existing programs and encouraging new emerging projects using USVs, if not, leading them on in some cases.
Okay, thank you, Jérôme. And we have a question from Chidong.
Yes, thank you, Jérôme, for the presentation. My question is also regard PI GOOS. And I just wonder how the PI GOOS work together with the PAC IOs. So what's the shared responsibility, and what are the unique responsibilities?
That's an excellent question that will need to be answered as the governance evolves. So we do have a distinct membership. So PAC IOS is the US part of IOS that covers the Pacific Island and the associated states of the United States. So take Marshall Islands, for example. It's an independent state with association with the US, but it is also a full member of SPC. So right now, the scope of PI GOOS is covers our island members of SPC. So we already, well, envisioning that this would happen, SPC has signed an MOU with PAC IOS years ago. For example, Jim Potemra and my colleagues, we're interacting regularly on, for example, interoperability of systems and data feeds. We're already collaborating on specific projects, sharing the, how do you say, sharing the work in the activities among the different countries. So right now it's done in very good intelligence. There's no, there is an overlap. There's, you know, not much we can do, and that should not be a problem.
Okay, thank you.
And I noticed Masha noted, put a few links on the website. I can on the chat. I can add the PICOS website, and there is no website for PI GOOS yet, but it has been registered, and it will appear soon. In the meantime, here's the website for PICOS. And noting also that PI GOOS used to be hosted by SPREP up until essentially last week.
All right, thank you, Jérôme. We've got another question from Christophe Menkes.
Yes, thanks. I think Meghan raised her hand before me, but whichever.
Oh, sorry. Do you? Oh, there's an order. Do you want to
Yeah.
go first,
Yeah.
Megan? Or
Anyways.
I think there'll be time for both.
No, Christophe, you go, and then I'll ask.
All right.
Okay, thanks. Yeah, I was thinking again to the automatic observing of the micronecton actually on cell drones. It's one thing. I think there is a huge gap, which is it's useful to have micronecton for fisheries, of course, but in general for the ecosystem, the understanding of the ecosystem of the Pacific. And within in that line, micronecton is near the top of the ecosystem. So one thing we would want to have actually is the middle trophic levels, the zooplankton, which can also be acquired by acoustics. Why not on cell drones? Possibly there are cell drones with zooplankton sensors, but well, of course fluorimetry, the proxy for chlorophyll. And I was wondering whether the automatic nutrient samplers that are out there can work also. I mean, we could envision a full suite of measurement that would really complement the physics up to the micronecton. Actually, yeah.
Thanks, Christophe. Yeah, that really is the benefit of USVs, is that you can fit all the sensors on board and have them powered and operating simultaneously and in real time if needed. Go ahead, Megan.
Okay, that is a really interesting idea, though, Christophe, and I really would support, yeah, getting that capability of the full trophic, all the trophic levels. That's exciting. My question was for Jérôme, and as somebody, you know, for the lead PI on this mission that is actually in Kiribati, EEZ, I really wanted to have a co-design element to this mission, and to be collaborating and have, have somebody from Kiribati or from the Pacific Islands on the team. But it's very hard for me to know these people, who might be interested. And I'm wondering whether the Pacific community could act as kind of a matchmaker, where you could help connect me with people who would be interested in being part of this team. And I know that there's the university there, and there's other places, but can you just talk a little bit about how to bring on people as team members?
I think there's something that we need to keep in mind is in many cases the really small size of those countries, and that includes the population and the number of people that can interact with such projects. I think that's quite evident when you're looking, for example, at the time it takes to get a MSR permit in some of our members' waters, is because they are struggling in terms of capacity. So obviously SPC is well placed to do that, because we all have existing projects and initiatives working with them, and fisheries is one of them. I think Christophe mentioned that in the chat. We have some contacts with the meteorology departments. So yes, we do have contacts. We're working actively in many ways with them, but they often have limited bandwidths. They are only sometimes, there are many countries where there is not a single oceanographer in the country. We're working right now, we're supporting the Met offices to include oceanographers within the Met services of the countries. Quite often, and I think it was illustrated in my presentation, as are the divisions in SPC, your two primary stakeholders in countries will be either the Met services with a more physical oceanographer type of profile, or the fisheries department, where you might also have some ocean specialist, if not a fisheries oceanographer. So yes, it is difficult, but it's not a reason to give up. There could be interest at the regional level as well. So, and SPC definitely has a role to play in that.
Okay, thanks.
Picking up on that, Meghan and Jérôme, Jérôme, have you got links with the Pacific Island Forum Fisheries Agency, the FFA? And I'm wondering, given USVs and their sort of ability to be quite interdisciplinary, is there a way that we could integrate team members, as Meghan said, who may come from different disciplines and who may have adjacent goals?
You can imagine that the relationship between FFA and the Foreign Fisheries Agency and the Fisheries Division at SPC is extremely strong. There are numerous projects together, and there's a working relationship between the two. So yes, that's definitely a possibility. But that's still staying in the fisheries domain. Also noting that I think that was stressed by Christophe and some of our other SPC colleagues, to understand fisheries ecosystem. You need to understand the ecosystem itself, so that can, the need for understanding, for example, surface heat fluxes and physical parameters in the ocean is key to understanding the tuna ecosystem, its migration and its life cycle. So yes, it's a work in progress. Also noting that one thing that PI GOOS will try to develop with our fisheries division is how can we get the fishing industry to contribute to more ocean observation, because they have tens of thousands of floats, instrumented floats in the region. Those are the FADs, the fish aggregating devices. And many of them can be equipped, if not already, with scientific sensors. They already have echo sounders, and then they transmit in real time. So there's some work to do in that area as well. Possibly for the regulatory part with FFA.
Interesting that you mentioned that, because our first speaker, Colette, her lab leader, Menina Rowan, is rolling out the fish soup. I think she's having a workshop on that at the OSM in New Orleans with the Fishing Ships of Opportunity program. But Colette, is there anything?
I'll make sure Menina is in touch with some of my colleagues. I haven't seen her in probably 10 years, but yeah.
We've actually rolled it out in New Zealand over the last few years, and now we have many fishing vessels in New Zealand equipped with temperature sensors on their equipment, and we've done some studies showing that's had a great impact on how we're able to forecast heat content in the coastal seas around New Zealand. And now Menina's been really successful at getting that off the ground in Australia. So,
and there's going to be a session at OSM on that?
I think so, yes.
Okay.
Yeah.
Okay.
We do have one last question. Jim, would you like to ask your question?
Yeah, thanks. I was just going to follow up on what Meghan had said, and back in the earlier days of PI GOOS, the coordinator position was absolutely critical for being sort of that ambassador between the scientific work that was going on and the countries there. So maybe as that coordinator position gets developed, and as PI GOOS starts to develop their terms of reference, I think that's something to revisit. In other words, having a central point of contact for any work that's being done in the region. And this, had back in the day, this instance where Meghan has a sail drone running through where Christophe has a cruise going, that would have been known to the PI GOOS coordinator, and they would have connected the dots early on. So hopefully we can get that going. I did want to ask, if I have time, actually, Colette, I know that the East Australia Current Mooring Array was removed. This might be an unfair question. Is that because of your study?
No, not at all.
Okay.
We actually did try to show its value. Funding, it was just funding. Basically, they were happy they had 10 years of data. Lots of people did studies on EAC seasonality and depth structure, and then they figured that they pulled it out, which was a big shame for us, because I guess we're the only group that was using it for like actual prediction rather than sort of past case studies sort of things.
Yeah, thanks.
Yeah.
All right, I think that wraps up the group, this webinar. So thank you so much for attending, and I hope you all got some value out of this hour. Thank you, and hopefully see you for the next one. And please reach out if you're interested in presenting at the next webinar. Thank you.